Hi, this is Adam Griffin with the second video for this week, and the question is number 50. Oops. So the question is, a rocket burns fuel at a rate of 5 kilograms per second, expelling the exhaust gases at a speed of 4 kilometers a second, and we would like to find the thrust of the rocket engine. So this problem is trying to get us to relate the mass of an object to its force when you're given acceleration. So we'll start with part A, where we have to model the fuel burning as a steady ejection of small pellets, and with each of the small pellets having a mass of delta m. So we should suppose that it takes a short time, represented as delta t, to accelerate a pellet to the exhaust speed. And we also know that the rocket is clamped down, so it can't recoil. So we have to just find an expression for the magnitude of the force that one pellet exerts on the rocket during the short time while the pellet is being expelled. So from our equation, force equals mass times acceleration. We can change that for this problem to the force of a single pellet equals our mass of a single pellet times acceleration. So since this is going to be, and I'll select this so you can see it better, since this is going to be our how it's represented in our final equation, we don't need to change that. So all we need to find is acceleration because it doesn't give it in the problem. So acceleration equals our final velocity minus our initial velocity divided by the amount of time that it takes. So our acceleration is, and since our initial velocity is 0 because it's with respect to the rocket, and it's going to be 0 because it's inside of the rocket, this is 0, so we have the velocity of the exhaust, which is 4 kilometers a second, divided by delta t. So we plug this in to this equation right here, and we get that the force of a single pellet equals delta m times our exhaust velocity divided by delta t. So for part B, we have to do this one where it says if the rocket is moving, the velocity of exhaust is no longer the pellet's speed through space, but it is still the pellet's speed relative to the rocket. By considering the limiting case of delta m and delta t approaching 0, in which case the rocket is now burning fuel continuously, calculate the rocket thrust for the values given above. So we have our 5 kilograms per second and our 4 kilometers a second, and we are trying to figure out how much force the fuel is exerting on the rocket. So because delta t is approaching 0, which makes it so that the rocket is now burning fuel continuously, we can use this fuel rate of 5 kilograms per second to model for that continuous fuel consumption. So we have our fuel rate, 5 kilograms per second, and our exhaust velocity, which is 4,000 meters per second, and we know that the units for newtons is kilograms times meters per second squared, which can be separated into kilograms per second times meters per second, and we see that those units match up with these. So all we have to do is multiply the two, and we will see that the force of thrust is 20,000 newtons. So that is how you do problem 50, and thank you.